We're going to first look at how to solve equations. I am going to assume that this is just a review, so it might be a little fast. When you're working for equations, you want to solve for x, so pick a place you would like to put your x's. Since 8x is bigger, I'm going to subtract 3x from both sides. Then I'm going to add 1, and then divide by 5. And I get a solution of x is equal to 3. Feel free to check that if you would like. On number 2, we have parentheses, so we want to use our distributive property. And this time I'm going to move my x's to the left since 12 is bigger than 5. That's just a choice. And then divide by 7. The next one, the tricky thing here, is if there's a minus sign, that needs to get distributed just like this 3 got distributed. So we would have 8 minus 3x minus 4 equals 6x. I'm going to combine like terms, so that's negative 3x plus 4. I'm going to add 3x to both sides and divide by 9. So you don't get always really pretty answers in math. Next one, we still have the distributive property. We want to distribute the 5. And here I want to distribute the negative 3. Collecting like terms, it's a lot of 7s. I'm going to add 7 to both sides. That is a 7. And then divide by 7. The next one, the same. We're going to distribute. Again, that's a negative 5 I want to distribute to both. And I need to distribute this 2. Collecting like terms, I've got 2x plus 50, I think. Then here I'm going to move my x's to the right. That's just a choice. I'm going to subtract 2, divide by 10. Now I don't want to leave my answer like that because I can reduce. Those are both divisible by 2, so you should reduce it down to 24/5. Number 6, pretty much the same, distributing the 2, distributing the 4, the 2, collecting like terms, so I have 14x minus 6 equals 14x minus 6. Now I can keep going, but I'm going to stop here because I have the same thing on both sides of the equal sign. This is a true statement. Whenever you have a true statement, what's going to happen is the answer for x would be all real numbers. Again, you could keep going. You could subtract 14x from both sides. You could add 6. You may end up with 0 equals to 0. But that's still a true statement. Don't stop there. The answer is all real numbers. Let's look at number 7. So I have 3x plus 14 equals 5x minus 10 minus 2x minus 14. Collecting like terms, let's see, that's minus 24. So that's not the same. But if I subtract 3x, what happens? I don't have an x anymore. How could I solve for x if I don't have it anymore? Well, do I have a true statement or do I have a false statement? I have a false statement. So the answer is no solution. We could use that symbol, or we could write out the words no solution. When solving equations, you just need to make sure that you keep your signs, collect like terms, put x's on one side, everything else on the other, and if you get a true statement, the answer is all real numbers. If you get a false statement, the answer is no solution. Part 2, we're going to be solving inequalities, and we want to graph our solution on a number line. I believe on the final exam the number line will be drawn out for you. You will just have to shade it in. You treat inequalities just like equations except for one small little detail, which we will get to. So here, getting x by itself, I'm adding 7 to both sides, and I get x is less than or equal to 3. So 3, I'm going to shade in the 3 because of the equal sign, and then less is to the left. Here I'm going to subtract 9. I'm going to divide by 4, and I'm going to reduce that to negative 3/2. So we have x is greater than negative 3/2. So not greater than or equal to, so an open circle, and then shading to the right for greater than. Here I'm going to subtract 1, and this is the difference. When I divide by a negative, when you multiply or divide a negative through an inequality, you have to reverse that inequality. So we have negative 1/3. Got to do that equal to, so x is less than or equal to negative 1/3. On this one, you really want to decide which side you want your x's. I'm going to choose to subtract 2x from both sides because I don't want my x's to be negative. I don't want to worry about reversing that inequality. So I'm going to add 1 to both sides. I'm going to divide by 5. So I have 16/5. Remember, that's like 3 1/5, not like, that is 3 1/5. But you have to read it from x. So x is less than 16/5, less than 16/5. I'm going to do the same thing on number 12. Since my 7x is bigger, I'm going to move my 3x so my x's stay positive. And I'm dividing by 4. But I still have to read this from x. X is greater than or equal to 3. That's to the right. Now 13 and 14 is what I call sandwich inequalities. You're really doing two inequalities at one time. You still want to get the x by itself, so you want to subtract 1 from all 3 parts. Then we're going to divide by 4, and you have to do that by all 3 parts. And now x is between negative 3/4 and 1, including both of those because of the equal to part, and you're shading x in the middle because that's where x is. So number 14, same thing. I'm going to subtract 8. You just have to do it from all 3 parts. Then divide by 3 because we're trying to get that x by itself. And now we have negative 3, negative 1, open because no equal to, and then x are all the numbers in between. And one more time, you could check by picking a place which you've shaded and going back to the original problem and checking to see if it's right or wrong.
On number 15 and 16, you're going to see a few more negative signs, so we need to be really careful. So on number 15, what we need to do is isolate our variable. So the first thing I'm going to do is I'm going to add 8 to both sides, and when I bring this term down, we're not going to forget that negative. So that's 0, bring down the symbol less than, and we have a 14. Now we need to again get x by itself, so I'm going to divide by negative 7. Now what happens to an inequality when you divide by a negative? You want to reverse that inequality and then just do the arithmetic. So 14 divided by negative 7 is negative 2. So we have x is greater than negative 2. So putting that on a number line, greater than, that's an open circle. All numbers greater than negative 2 are to the right, like 0, 1, 2, all of those greater than negative 2. Number 16, same thing. We need to isolate the term with the variable, so I'm going to subtract 5 from both sides. When I bring this down, I want to make sure I carry that negative. That's 0. Bring down this symbol that stays greater than. A negative 19 minus 5 is a negative 24. dividing both sides by a -4 to get that x by itself. I now have x, because those divide to make 1. And again, I have divided by a negative, so I reverse that symbol. Even though a negative divided by a negative is a positive, it's what I did to get there, which is dividing by a negative. Reverse that inequality. So now I have x is less than 6. So again, an open circle for just less than, and less is to the left.
Next part would be setting up word problems. The directions on the final exam use equations and algebraic methods to find the solutions. We will not just accept answers. You have to use those algebra methods. So find 3 consecutive odd integers. Well, you have to remember odd. X would be the first one, x plus 2 is the second one, and x plus 4 is the third one. You might want to review your notes, but odd and even are going to be set up the same way. So I have 3 odd integers whose sum, that's why I'm adding them together, is -21. So collecting like terms, subtracting 6, and dividing by 3. And don't stop there, because we're supposed to find all 3 of them. So that's x. So x is -9, x plus 2 is -7, and x plus 4 is -5. So you're coming back here and finding all 3. You could add them up. That would equal to -21. Now remember, that's odd. Look at the next one. Just 3 consecutive integers. Not odd, not even. So the first one's going to be x, the second one's going to be x plus 1, and the third one's going to be x plus 2. So whose sum is 39. So collecting like terms, subtracting 3, and dividing by 3. And one more time, don't stop. We want to find all 3, so we have 12, 13, and 14. Remember, consecutive means in a row. Okay, so look at number 19. Now we have the word even. So we set them up just like the odd ones. Believe it or not, just like the odd ones. So we'd have x, x plus 2, and x plus 4. So we want to add those together and set them equal to -60. And again, not stopping, so if x is -22, x plus 2 is -20, and x plus 4 is -18. 3 consecutive even integers. Now we need to talk about a perimeter of a rectangle. Well, I do this by drawing a rectangle, and remember, a perimeter is all 4 sides. So the length is 2 feet more than 3 times the width. What's mentioned last is usually x. So the length is 2 feet more than 3 times the width. So that's 3x plus 2. So my perimeter would be twice the width plus twice the length equals the perimeter. So 2x plus 6x plus 4 don't stop. It says the dimensions, right? So the width is 4, and the length, you're going to put 4 in here. 3 times 4 plus 2. That's 14. And I guess we should put feet because it was all in feet. And then one more word problems back to the perimeter. So I'm going to go back to drawing my rectangle. The length is 7 feet less than 2 times the width. So again, I'm going to let x be the width. The length is 7 feet less. Now when you do less than, you have to subtract 7 feet from 2 times the width. And my perimeter is 64. So 2 times each side, twice the length, twice the width, equals your perimeter. So dividing by 6, I get 13. So 13 is my width. And again, I guess this is all in feet. Now my length is 2 times 13 minus 7. So what is that, 19 feet is the length. So looking at the word problems, you need to know the perimeter problems, money problems, and consecutive integer type problems.